Okay, so this is the Open Policy Agent project update and introduction. Just to kick things off with some intros. We have Rita Zhang. She's an engineer at Microsoft, Gatekeeper maintainer, OPA contributor, as well as me, Patrick East, engineer at Styra, and OPA maintainer. All of our Slack and Twitter details are there. Please come track us down with questions. So to talk about OPA, I think the first thing a little bit is to give some context on what it is, what we do. So the goal for OPA, the Open Policy Agent, is to provide a unified policy enforcement layer that can be used pretty much across the stack, particularly in the cloud native environment where you start to see dozens, hundreds, thousands of services interacting that probably all have their own authorization engines and their own way of declaring the policies, and it becomes a mess. So in comes OPA. It was founded by Styra, open source, donated to the CNCF. Currently, incubator project. It's, let's see, we're up to 70 plus different contributors. That says 1,000. I think we're at like 1,200 or something people on Slack. It's continually growing. We're seeing a lot of popularity in a huge number of use cases. I think this is KubeCon. Most people here talk about Kubernetes, so admission controller for Kubernetes is kind of the main one that a lot of people think of, but it's also being used in a lot of CI/CD pipelines, as well as things like microservice API authorization. There's a ton of users. The list here sort of speaks for itself. It's not just a pet project. It's being used in production in many large deployments.
And you probably also heard Torin from Styra, who
Yes.
talked about OPA this morning, and all the places that OPA has been utilized across CNCF projects.
Exactly, yeah. Thank you. So that gives some background on OPA, but this is the intro. Some of you are probably wondering, what is OPA? Why are we here? OPA is a declarative general purpose policy engine. The very core is Rego, as Torin explained earlier. It's the policy language that you use to define your policies. OPA is basically an evaluation engine for them with a collection of services and other features around it to do policy management, authoring, editing, logging, all kinds of stuff. Anything you need basically to build out the full authorization service. Thank you. The engine itself is all written in Go. Primarily, it's being used as a library or as a sidecar. So OPA does have a HTTP service that you can start up. You can evaluate queries. You can push data into it, policy, all these things. Or embedding it with Go, you have access to all the same things via the APIs. There's another one that's not on here right now, which Torin announced at the keynote, which is the WASM integration, so you can start to evaluate your policies with any WebAssembly runtime. Next up, the management APIs. This is really where things start to get pretty cool. Evaluating the policies is one thing, but knowing which policies were being evaluated for any particular decision, being able to centralize your policy management, pushing updates, doing all kinds of profiling, auditing. There's groups that are looking into doing like formal verification, all kinds of cool stuff for these policies, and that's really the icing on the cake. Last but not least, tooling. If you can't write the policies, it's not very useful. So there are integrations for VS Code as well as the Rego Playground, which hopefully anybody who's writing Rego policies has seen. And a rich CLI package, because that's kind of the primary entry point for any new features into OPA.
I'm also curious how many people here have used OPA already?
That's a good question, yeah.
Awesome.
Okay.
I'm just curious how many people have tried OPA Gatekeeper? Awesome, thank you.
Okay, so we talked about what OPA is, but by itself it's not super useful. You have to have things to evaluate policies on. The inputs for these policies are basically any JSON, the output also any JSON. Usually this boils down to some API request, some admission request. You have some structured data that's coming in that says this is the request being made, this is the JOT that came with the request, it's the YAML for the admission request, the output being a allow, it's a Boolean, yes or no, or in the case of something like a mutating webhook, you have a JSON structure that comes back out and defines what the result should be. The service box in here, somewhat ambiguous. It really can be pretty much anything. The queries, these requests, like I said before, if you're using the sidecar model, most people are doing HTTP requests. It's very easy to extend to OPA, so there's also like the Istio Envoy integration uses gRPC. It's very flexible in that regard. You just have to open up a transport path to give JSON to OPA, and that's pretty much it. The integrations, hopefully, as a show of hands, who all saw the keynote this morning where we probably saw the same slide? Okay, cool. So not super new. As you guys know, basically the integrations are becoming like pretty wide and pretty deep. I think you'd be hard pressed to find some category in the CNCF landscape where you don't have an existing integration with OPA or an opportunity to integrate OPA. The primary use cases, these are things that we see a lot. So if you're still kind of new to OPA, wondering how you might use it, how do you leverage this in your system? Admission control, like I said before, we're here at KubeCon. This is like bread and butter. Everybody who's got a Kubernetes cluster should be doing some kind of admission control. The like next kind of big one, API authorization. We're seeing a pretty big uptick with like the Envoy Istio plugin. Basically being able to push these policies to getting enforced outside of some service that you implement, but still very close to the service. You kind of want to avoid having that long jump because it's an API request. You don't want to sit there and have a 5 millisecond delay or something like that just to authorize it. Data protection is kind of an interesting one. You see there's a good talk. I think they're all recorded from the OPA Summit. There was one that Pinterest did that's pretty cool about doing their data protection. I'd recommend you guys go check out the recording for that when they're posted. I don't think they're posted yet. All right, next slide. Okay, so this is a little bit more on the updates. There's a lot of, like, since the last KubeCon, well, especially since the last North America KubeCon, since like Barcelona, there's been a lot of interest in CI/CD pipelines and open policy agent. There's tools that are becoming pretty mature, like ConfTest and some other like integrations with Spinnaker. There's a new project called Boomerang that just got released. IBM published this not too long ago, as well as things for Terraform. And this is all using basically the inputs for what you're going to use in your Terraform templates, for your YAML deployments, for any kind of like CI/CD pipeline, validating them using OPA with policies to make sure that you're compliant, and then checking that, pushing it as far left as you can so that your developers get that immediate feedback. The change they're trying to push, it gets caught first thing on the pull request by the CI system. The next bullet point, there's been a ton of changes for having OPA support object storage for bundles. If you're new to OPA, you may not know what bundles are. If you're using OPA already, this might be exciting. Basically, the de facto way to push and manage policies with OPA is using bundles. You right now need a HTTP endpoint to get them from. There's support built in now for OPA to do the signing and verification, authorization that you need to pull them out of S3, GCS, as well as spec and support for OCI. So basically any OCI image registry could also contain policies as layers in there. Speaking of integrations, new integrations, there's now an integrations page on the OPA docs. It's not complete. I think anybody here who knows of more or works on one, please do go at it. This is all just open on the website for OPA. As you can see, it's pretty wide, but largely dominated by Kubernetes things. There's Istio, Envoy, the Kubernetes admission controller with Gatekeeper, which we're going to talk about next. Kubernetes and OPA, they go hand in hand. The admission controller, it gets used by pretty much anybody that I know of that's doing, like real production deployments in one form or another. It may or may not be OPA, but OPA gives you an extremely powerful tool to leverage doing leveraging external data to do contextual policy enforcement for these objects, which leads us to Gatekeeper.
All right, so for the rest of this talk, we're going to talk about the Gatekeeper project and also some updates for folks who have been using it in the wild for a while. And we have a demo. It wouldn't be a talk without a demo.
Of course.
So what is Gatekeeper? So we're at KubeCon, right? So a lot of companies probably have their own company policies, maybe some compliance requirements or legal requirements. And so a lot of admins ask, how do I actually enforce these policies on my Kubernetes clusters, control what my end users can actually do? Echo, echo. And how do I actually do this without writing an admission webhook every single time? And so that's what Gatekeeper is. It's a customizable Kubernetes admission webhook that enforces policies and ensures governance for all your clusters. And what it does is it allows you to write your policies as configurations rather than code, and you don't have to recompile it every time. So some of the motivations behind the project. As I mentioned earlier, with Gatekeeper, you should be able to control what end user can actually do on your clusters. And it helps admins and a lot of companies to ensure that their clusters at any given moment is actually in conformance to the company policies. And when the clusters are not in compliance, then we actually present an audit capability that allows you to identify the resources that are actually out of compliance. And last but not least is actually something we developed since Barcelona KubeCon, which is enable a lot of the cluster admins the ability to roll out policies in a production environment. As all of us know that a lot of policies are actually created, or the thought for new policies are actually, the requirement for new policies are actually there after your cluster has been running for a while, right? So then a lot of people came to us and said, well, how do I actually test my policies and build confidence in my policies in these production clusters without actually impacting existing workloads? And so we developed this feature called Dry Run, which allows you to deploy your policies in cluster, and you can actually look at the effects of the policy on your cluster without actually impacting your end users. And last but not least, we have the cluster admins and we have the developers, right? So how do we make sure we have a cluster that conforms to company policies, but without sacrificing developer agility and autonomy? So how do we get here? Back in 2017, Styra released V1 of Gatekeeper, and for a lot of you, I think you're probably running the V1 in production, which is started back in December of 2017 in the KubeCon in Austin, and that is the version that is running Kube management. And so in December 2018 in Seattle, Intuit, Capital One basically start using V1 in production. And that's around the same time that Microsoft released V2, which is called Kubernetes Policy Controller, and it was donated to OPA. And around the same time, Microsoft, Google, Styra, and others basically started to collaborating on this project. And back in May in Barcelona, that's when we released V3, which is built upon the constraint framework, which allows you to deploy your policies as CRDs rather than config maps. And then now we're here in November, KubeCon San Diego. This is when we actually release 304 Beta 2. Some of you may have been running it for a while, and we're going to talk about some of the new features. So V3. So V3, this is a diagram of what the Gatekeeper architecture looks like. So as you can see, at the center of Gatekeeper is OPA, and OPA is, again, the policy agent that actually runs the logic of your policies. And the data is then replicated into OPA from Gatekeeper. And as you can see, the policies are now created as CRDs as opposed to config maps. And we created this concept of policy templates and policy instance. So what do they mean? So think of a function. So a template is a function where you write the rules. And you write the regos, the rules that describes what kind of rules that your policy should actually execute. And then the instance, the policy instance in this case is the caller to the function that passes in all the parameters. So what this allows cluster admins to do is be able to reuse the policies over and over, and just by passing in different parameters to the actual policy instance. And we'll see that in a little bit. We will have a demo that demonstrates that. And another thing that Gatekeeper does is, in the case where you want to have referential policies, so for instance, if you want to look at, do I have unique, does my ingresses have unique hostname, right, as an example. So for those type of referential policies, OPA is really great for that, because it's basically a cache of the resources in your cluster and allows you to actually do these comparisons between the object that you're trying to create at emission time as part of the emission request, and all the resources that already exist in your cluster, right? So so I guess you're looking at it that way. So yeah, so the admin does a kubectl create or apply, the resource gets emitted to the API server, and then the API server offloads calls the Gatekeeper emission webhook, and then the Gatekeeper then takes the request and passes it into OPA for actual policy execution, and then the OPA returns information back to the API server as a deny or allow. And then all of that information is basically how Gatekeeper works. And as you can see on the very, very left, we also have the audit capability, which basically runs all the policies against all the resources in your cluster every so often, and the audit results are then populated as part of each policy. And again, we'll see a demo of that in a bit. So I'm curious how many people are actually running V1 right now. Okay, so this slide is for you. So we got a lot of questions on Slack about the difference between V1 and V3. So this is a table basically describes that. And again, so V1, you have kube management. Again, it's something that we're continuing to maintain, but not a lot of new development there. And then V3 is where we're doing a lot of new development, and we'll continue to add advancement there. And in terms of policy management, in V1, the raw regos, the raw logic, basically are stored in config maps. And in V3, now they're created as CRDs, and the raw regos are stored in constraint templates. And again, you can basically pass in specific policies that uses those regos as constraint instances. And some of the feature differences, as you can see, V3 has still, V1, V3 both have contextual awareness, referential policy, and then V1 has validating emission control, V3 has validating emission control, V3 has mutating, V3 does not have mutating yet. We're still working on that. And then both have multiple sources, so you can write your regos in a library format and then import those libraries in your rego. And then in V3 we have audit, we have dry run, and as we mentioned before, there's also CI/CD with conf test, and then all in all, this enables you to reuse the code you already have, right? So yeah, so some of the core functionalities, validating emission controls where end users can actually do in the cluster. So when they actually create something that they're not supposed to, or they might know that, hey, I should have resource limits on these pods, but they just didn't do it. And so this is really for us to enforce them to make sure that they do the right thing. Context aware, again, because we have OPA, we're now able to do referential policies that compares one object against every other object in the cluster. And once again, constraints really allows us to parameterize and make it easy configurable for admins to scale and expand on the policies that's already written. And constraint templates, again, is the source code of the constraints. They're easily shared, testable, and they can be shared across the community. What we've also done in V3 is we created this library of all the constraint templates that's created by users in the community, people who have like similar requests, and we can show that in a bit. And the thought behind that, currently it's only a folder under the Gatekeeper repo, but the thought behind that is we will eventually have a repo that has a library of all the Kubernetes policies that people love, and it's tested and it's supported by the community. And last but not least, there's audit. Again, it allows you to look at ongoing monitoring and health of your cluster and detect any detect and remediate any pre-existing misconfigurations. So new features. So again, the new dry run feature allows you to test canary releases in a cluster in stages without actually impacting your users. And this allows admins to gain confidence in the policies that they're deploying. And it allows you to have gradual rollouts. And we've also added namespace selector to narrow the scope of resources that a constraint, the actual policy can enforce, so to certain namespaces only. And again, these features were basically requested by users of Gatekeeper. And policy library is this concept of community developed policies, and we've also developed a bunch of alternatives to pod security policies for those of you who might be interested in seeing, hey, I wonder if I could use Gatekeeper to enforce pod security policies as opposed to turn it on all at once. And so we also added support for multi-source constraint templates to allow you to write your Regos as libraries and import the libraries within different constraint templates. And last but not least, we also introduced metrics. So now we have metrics added to Gatekeeper, integrated with Prometheus. So we have a demo in a little bit that shows you what are some of the data that we're scraping. All right, so demo. So a fictitious bank that builds, that has like high transaction day to day, and it's a very highly regulated industry, and both developers or admins are not happy because admins want agilities and they want quick turnarounds. Meanwhile, admins are like, well, I just want to make sure my cluster is safe. I want to make sure everything that's deployed is actually supportable. So how do we get around that? So Agile Bank has these policies, and some of these may be familiar to you as well. So I wonder if there's a way for us to make sure that all namespaces have point of contact as a label, so that in the future, admins can actually contact the people that have created the resources. Another one is all pods should actually have upper bound resource usages, so we can limit what the impact a specific application can have within the cluster. Also, for security reasons, all images should really be from an approved repository. You probably don't want your users to just pull from the internet, right? And all services should really have unique selectors. And the last one a lot of you probably have already seen is ingresses really should have globally unique host names. All right, so so we're gonna go quickly into our demo. So I think you're the admin.
All right.
Oh, you're the developer.
So I'm a developer. I work at the bank. I create my new advanced transaction system. It's a very advanced project, but 5 weeks go by and I'm actually working on a new project now. That one was left behind, long forgotten.
So our intrepid admin finds it and says, well, what is this advanced transaction system and what do we do with it and what do we use it for? And so we go on a 3-day quest across all the departments, and in the end we find that the project was scrapped. Never again, says the admin. And now the admin says, well, I've heard of this project called OPA Gatekeeper. I wonder if it can actually help me with this. And so let's see some of the constraint templates that I will be deploying. So as you can see, as we mentioned earlier, those were the policies that Agile Bank wanted to enforce. And here we have a bunch of YAMLs, basically describes what those policies are, and then we'll show that in a little bit. And so first I'm going to apply and deploy these templates into my cluster. And once they're deployed, these constraint templates can then be utilized. And let's see what a constraint looks like. These are the constraints that actually use the constraint templates. And as you can see, we have container must have limits, owners must be provided, and production repos must be coming from a particular repo, and unique services must have unique selectors. So let's take a look at what a constraint actually looks like. Here, as you can see, using the Kate's require labels constraint templates that I've already deployed previously up here, right? And so using this kind, I'm creating a customer resource of this kind, and I'm matching on the namespace resource. So what this constraint is saying is for namespace resources, these are the labels with this regex that I want to make sure that all namespaces must have, right? And so, again, imagine you can deploy this for your cluster as well, but instead of namespace, you could have on services or pods, and then you can have your own parameters and regex as an example. So I'm going to go ahead and apply this constraint.
So now when I try to create a new production environment, I'm going to get an error back because I did not add the label to this. The error is descriptive.
How did you know?
It says denied, all must have owner, and the nice error message that says all namespaces must have an owner label. Knowing this, I go back, I edit my file, well, I make a file, I didn't have one before, and now I have one with the label saying the owner is me.agilebank.demo. I can attempt to deploy this, and it will be allowed through. There we go.
All right. So now he's able to actually self-correct, and he didn't need to get an admin to create a namespace. And I just forgot that I'm supposed to start Prometheus.
Oh.
So you're going to have to forgive me for this. All right, so while this is running, let's continue.
All right, so we've created the new namespace. Everything looks good. Now I'm going to try and create some resource, and I'm going to use a bad repository. I get same kind of error message. I get that immediate feedback without having to ask the admin what to do. It says there's an invalid image repo, tells me the repo, and then it tells me which ones are allowed. I then can go and edit my file and deploy. This one, using the correct supported repository, is allowed through. Similar issue with the duplicate service. I'm going to attempt to create one. It's going to have the service name is going to be a duplicate here with the selector controller manager. We're not allowed to override that. Without Gatekeeper, this would be really bad. And Sure enough, Gatekeeper says no. It says that you're not allowed to do that. It's already in use.
And it tells you which namespace and another project is actually using it.
Yeah, exactly. All right. So we've seen that Gatekeeper enforces those policies. All's well in the world. Like most good clusters, there's an outage. Bank is down for hours.
Well, we have no idea where the resources, why the resources are without resource limits. Now they're causing issues in production. We need to get all the resources in the cluster that don't have resource limits. And there's not really an easy way to do that right now. So let's actually see if the audit results within the constraint must have limits constraint actually can give me that information. So I'm going to go ahead and get the constraint must have limits constraint, and container must have, I keep saying that. And as you can see here, the audit, this is a timestamp that the last audit ran, and as you can see here, total violations is 1, and the violating resource is this pod running in the default namespace, and this container does not have any resource limits. So this is super helpful. Now I can just go in and update and make sure this pod has the right resource limits.
So weeks go by. We now have this new policy. We want to roll it out to production. I'm sure anybody here who's already using a webhook has felt the fear. When I hit enter, is the cluster going to go down?
How many support tickets am I going to get this week?
Yeah. So we need to check. We need to make sure that all the host names are unique, but we don't want to just deploy and enforce. So now we're going to, sorry.
So, yeah, introducing new policies is dangerous, and it can often introduce a breaking change. So how do we gain confidence, right? And we can do that with
Dry run.
the dry run feature in Gatekeeper. So we can actually preview the effect in the cluster without impacting the workload and our users. So let's see what the actual policy looks like first. So actually first we're going to go ahead and deploy this policy, the constraint template, and then next we're going to deploy the constraint. So let's actually take a look at what they look like, right? We keep talking about Regos, but we haven't actually
seen any
any
yet.
Regos. How could that be? Anyway, so here's the Kubernetes unique ingress host constraint template, and as you can see here, this describes the CRD spec of the Kate's unique ingress host kind, which will be later used by the constraint to pass in parameters, right? And as you can see here, within this constraint template, we have the actual Regos here, the source code, and within here, we actually have 4 resources of ingress kind, right? And that the host names are identical, but not the same ingress, right? Where the namespace and the name are actually different. So in those scenarios, we know the ingresses are different, but the host names are the same. So go ahead and just reject this as a violation, right? As a violation, and display an error message, ingress host conflicts within an existing ingress, and return the host name to the user so that they know why it's complaining. So next, let's take a look at what the constraint looks like, right? So as you can see here, the constraint provides parameters, but it also provides, hey, here are the resources I want you to actually enforce this policy on. And as you can see here, we have the ingress kind and all the API groups that Kubernetes offers. And last but not least, this is the key thing that enables dry run feature, which basically says, for this particular policy, I want to make sure the enforce action is dry run, not enforce. So let's take a look at what that looks like. So before we do that, let's see if we actually have ingresses in the cluster. Oh, it looks like we have 2 ingresses in the cluster, both deploy to default namespace, and the host names are exactly the same. So this is pretty terrible, right? I don't know how they have their applications up.
It's not working.
This is terrible. So next, let's see, we now look at the unique ingress host constraint. And within this constraint, as you can see, we have total violations 2, and it actually identifies the ingresses that share the same host name. And this is super helpful because as an admin who deployed this policy, now I know, hey, this policy actually works. And the developer at the same time, let's see what if I try to deploy another ingress? Would it block me, right? So here we have a bad ingress. As you can see, same host name, just different ingress, right? And because we're in dry run mode, it should not block me. All right, so it was created and everything works, but I built some confidence in the policy that I just rolled out. All right, last thing, we have also added the Prometheus.
I was going to say, we just started Prometheus. What was it doing?
Good question. So we have, let me make sure it's up and running. So we added the metrics feature upon request by yours truly. And so here, as you can see, we have some metrics that is scraped from Gatekeeper that really helps admins. Again, for this cycle, we are focusing on admins, like how do they get more insights into how Gatekeeper is running in the cluster, what are some, how many total constraints are there that people we have in the cluster, how many violations we're getting per constraint. And then, in terms of requests, are we actually getting denies or are most of them allowed, right? So let's take a look what that looks like. So as you can see, these are the allows and these are the denies. So these are the requests that Gatekeeper denied within the cluster. And then let's see constraints. I wonder how many constraints we have. And as you can see, as we deployed earlier, we had 4 constraints that were denied, running in deny mode, so enforce mode, and then 1 constraint that we just deployed, the ingress hostname 1, and now it's in dry run mode. So this really gives a holistic view to admins, hey, these are the Gatekeeper related resources running in your cluster, and here's how they're doing. And we will be adding more more resources here so that we can do a lot more with the Prometheus reports. Cool. And if you have any like thoughts around this and things that you want to see in the project, please come and talk to us after this or in the
Meet the maintainers.
Meet the maintainers stuff. Yeah. All right. So with that, whoa.
So I think we're getting close on time,
Okay.
if not.
So the current status for Gatekeeper is we're still in beta, and for the next release cycle, we're gonna focus on production readiness. So think of again, this is why we're working on metrics. HA. Things that make sure that this is production ready before you actually roll it out to your clusters. And then there are folks who are continuing to look at mutation. And another feature that we're really excited about and we really would want more feedback and requests and user stories on is external data, right? So imagine when you get a mission request, in addition to the request itself that has like Kubernetes information, what if there's a way where I can call an external data source and get data into OPA and also use that information as part of my policy? That would be pretty awesome. So this is one area we're really looking for user feedback and to drive this feature home. And then, of course, more audit features, more metrics, and more policies from the community, such as yourselves, and also more developer tooling around this. And some people also mentioned authorization, but we heard like 1 request. So if this is something you're excited about, please also come and talk to us.
All right, so I think just wrapping up now, come join us. As Rita's been saying, if you have use cases, features you want to see, please don't hesitate. File new issues on GitHub. Come join us on Slack. There are weekly meetings for OPA as well as Gatekeeper. They're all open. Anybody can join and chit-chat with us.
Yeah. Thank you.